أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Good morning viewers. This tutorial is coming to you from Zaria, Kaduna, Nigeria under Tekla Structural Designer 2018. Today tutorial we are going to cover some presettings of the software after installation. This software is recently installed and will be shown to people how to do some pre-settings before using the software. Now we'll open the software to start the settings. This is Tekla Structural Designer, a software created by Trimble company. Trimble is this company that created this software, that is Structural Designer, with the other version of software Tekla Structures and Tekla TED and Tekla Fast Track. So Tekla TED is a package which is very good for academicians and students, while Tekla Structures and Structural Designer are softwares that are good for practicing professionals, most especially structural engineers. Tekla Structural Designer is a version of structural software that is good for structural designs and analysis, while Tekla Structures are softwares that are good in modeling structural elements and sometimes used for analysis, but are not that very good in designs, while Tekla Fast Track are software mainly used for structural design and analysis of steel members and structures. So this is the interface of Tekla Structural Designer, as you can see. Now for you to start your settings, these are settings, materials. If you want to update your software online, these are updates to check whether you have update. This is the lesson we are using. Now we have settings here and we have settings in the other sites. Now our main concern here is we have our general, the languages, the appearance, the auto-save, confirmations, update. We have results viewer. If you wish, the style of result, the way the result will be appearing, the formats, this is where you will touch. We have how reports usually come out, the style, the page option, the table, how the table will appear, the documents option, and how you insert your pictures. Then your unit, you set your unit. Then the design codes is under. As you can see, you can change the code you want to use. We have codes here, so we are setting our program to United Kingdom BS. If you can see, we have BS, United Kingdom BS, British Standard, and United Kingdom Eurocode. We have codes from Australia, Europe, Finland, India, whatever, etc. So we decide to take BS. Then we have our design options. These are our design options. So our concern here is the reinforcement. So our reinforcement here of our members, as you can see, these are our concrete members. that we are going to be dealing with in the structural designs. So like under beam, we have what we call reinforcement. So you decide your minimum reinforcement in your beam and your maximum reinforcement in your beam. Now this is our minimum bar in our in our beam, element beam. Now as you can see here, the grade is 500 and the type is type 2. So you might have another way of setting it. So we want to change this to 410 that we do usually use in Nigeria. That is our grade of steel. So where we are going to go to change it will be under material. So I'm just showing you to see where you are going to touch your minimum and maximum. As you touch this place, that is how you are going to touch all the other elements. This is what we call the detailing. How you want your detailing to be appearing in your beam. This is longitudinal bars. Use same size bars in multi-layers arrangement. Use same number of bars in no. It can change the top reinforcement and the bottom reinforcement different diameters and the layers, same number of bars. No, up can be 3y20 while down can be 2y20, or down can be 3y20, up can be 2y20. The cut length, rounding increment 50 mm is okay. Longitudinal bar curtailment, as you can see, match identical longitudinal bars. This one is okay as default. Then we have our end support sculpting. It is asking you whether you want to extend top span bars to extend to end support. We think that one is not necessary. So this is our link. So it will be selecting the systematical links in support region and also same size for both elements. So now if we want to change our material, as you can see, all these are the same with other elements. Our main concern is the material now. If you can see, this is material. We want to interact material. Let's see the reinforcement here. Our main concern, as you can see, this is steel, this is section. They are all under metric unit of measurement, and our code is BS. Now under section we have, let's say that our concrete. Now material, we have here varieties of material. Timber, we want concrete, and this is our grades of concrete. Now if you want to add another grade of concrete, you come to add. We have reinforcements here. As you can see, we have grade 500. Now the grade of our concrete, that our reinforcement that we usually use in Nigeria is 410, while IS Indian standard is 4115. So now here all the settings here are okay, but the grade of concrete we are going to add, sorry, the grade of reinforcement, the grade of that is our FY. Now here we will say add, so it will give us a chance of adding. We have our 410, and under our 410, the modulus of elasticity of the 410 is the same, 200,000. Now our prefix for the bar, we'll change it to Y, to be labeled Y now, and our partial factor is the same thing as 1.15. So now the new name, it will be 410. Now when you say OK, it will appear here. So as you can see, we said 410, but other materials here are not available, the size. But if you touch 500, you see size, that is the diameter of reinforcement here. So now you go back to this, we are going to be adding. But before we started adding, we'll go to our 500. If you can see this, you can view the parameters of 8. That is diameter 8 of the reinforcement. These are the parameters. So same applied to this. Now we'll say add, sorry, not this add here. It will give us this chance of of imputing. Now we'll start with let's say 8. Now 8 has some properties. It has some properties. Now the diameter should be 8. Now as you can see, the area of this diameter, the area should be 50. As you can see, the sign of warning will go. Now the total length of that Y8 is 12 meters. In Nigeria, mostly is 11.5. Mostly 11.5. Now mass per length, we have what we call mass per length. For Y8, it is 0.40. As you can see, the warning has a go. Then when you say OK, here you see we have added Y8. Then we go again, we added the next diameter, let's say 10, the name. Now the diameter of the bar, we see 10. As you can see, the warning are going. The area is not correct here. Our area is 79. Now the bar length we said is 11.5. 11.5. Now the mass of the the mass of the diameter of 10, it should be 0.62. As you can see, it has gone, the warning. Now OK, we have added. Now you add again, we add 12 mm diameter. As you can see, here is 12. Now the area is the same. We are going to change this 11.5. Then we OK it. Then we add again. Now we are adding 16 mm. The name of the diameter, it should be 16. As you can see, the area has changed. Now the area of the reinforcement should be 201. Now the length of the reinforcement should be 11.5. And also the mass will change. The mass will be 1.58. So you see, the sign of the warning do usually go. So you OK it. As you can see, we have added 4 diameter of reinforcements. Now we can add more. Let's say we add 20 mm. Now here we have our let's say 20, the name. The area should be yes, it should be 314. Yes. Then the length of our reinforcement is 11.5. The reason why our own don't usually reach 12, mostly if you measure, they are 11.5 in Nigeria, those roadside reinforcements. So our mass for our 20 mm should be 2.47. as you can see, they have gone. Say okay, we have added. We will add another one, let's say 25 mm. Now 25, we add 25 as the diameter. The area here should be 491. Then we have our length 11.5. Then the mass of our 25 mm should be 3.85. as you can see, it's okay. We have added let's add 32 because there is need for Y32. Now we add, we see the name should be 32 mm, the diameter is 32, and the area of 32 should be 6.31. Sorry, yes, no, it's not, it should, sorry, it is 8 because the other one is 491. This one should be 804. yes. Well, this one would be 11.5. then the mass should be 6.31. 6.31. These are the properties of 32 mm. Okay, now we add for 40 mm. 40. Now we have our 40 as our diameter. We have our 1260 as our area. Then the length 11.5, and also the mass per length should be 9.8, I think, yes, 86. It should be 86, yes. Then we say okay. Now as you can see, we have added. The same way grades of steel of 500 has its own materials, that is applicable to 410. Now this one, as you can see, is labeled as Y, while this one as H. Mild steel and high yield steel. Now if you can see, that is for concrete. If you want to set for your steel, this is your section. If you want to manage sections, so here these are our sections for steel. These are for connection. So this one you will add. So we do usually add if you want. We have plate dimensions, sorry, connection resistance. We have a managed section. So our concern today is our concrete design, not steel design. Now that is why we set everything to concrete. Now these are our material. We have added our materials. Everything is there. If you close, you don't have problem. When you go back again, you see your settings there. Your settings are there, as you can see. We are under this. If you want to design using this grid, you can use it. If you want to design using this grid, you can use it. Now if you go back to your settings here, under your reinforcement here, as you can see, we have our, for beam minimum. If you come to this, you will see this has appear now. So we can set our minimum reinforcement should be Y16. Then you OK it. Then your maximum, you change this. Your maximum, you can make it to be 25. You OK it. As you can see now, minimum side bars, we can leave it as 16, which is very, very okay. Now you can set your minimum top steel clearing space. That is your your cover, reinforcement cover. So we can make it to be 30. Minimum bottom clearance space, your reinforcement cover 30, which are very okay for our beam. Now the tension steel spacing, cross-sectional steel spacing. Now our spacing of reinforcement, the minimum will be 200, which is very okay. Now if it exceeds the 300, it's okay. Now using single bars when beam width, now this one too is okay. So as you can see, we have set our reinforcement for beam, detailing here, top. Now longitudinal bar, the pattern we want. So you select the patterns you like. Here we have different pattern: longitudinal bar pattern, standard pattern setup. We have standard pattern 2, as you can see. We have pattern 3, as you can see, they are changing. We have pattern 1, as you can see. So we'll select pattern 2, which is more mostly is the one that we usually use in our country. But pattern 1, 2 is very somehow tedious for the bar bender. So I may suggest pattern 2. Now default pattern, longitudinal default pattern, as you can see. For the longitudinal, we'll make pattern 2. So we have single span. Single span, you may decide to have pattern 1 or pattern 3, but I will suggest pattern 2. Then we have cantilever. Orientation for the cantilever, if you wish, no. Pattern 3, no. So I will suggest pattern 2, as you can see. So this is it. Then your bottom longitudinal reinforcement 2. So the same applicable, pattern 2, as you can see. And the single span, pattern 1, as you can see. This is pattern 2, so pattern 1 is okay. Then we have default, pattern 1 is okay. So cantilever 2, we'll pick pattern 2, no, pattern 1, which is very okay. Now these are darts, as you can see. This one pattern 2, no. So pattern 1 is better for the bottom longitudinal reinforcement. Then for the links, too, you have different settings. We have open links and closed links. So ideally, you come for the bar. We have maximum and minimum. So we would like to set the grades to this, and we'll make it 10. Also, the maximum should be 10 under grade 410. Now minimum spacing 100 and maximum spacing 300. Now we have the open and this. We have two type. Now the link type, we have the open type and the close. So we select the close, this one, the close type, which is very okay. Now you go to your general, that is under beam. You have your general. So under your general, these are not that the size of the the size of the the size of the aggregate you use, 20 mm, and cover and spacing check parameters. So this one is very important for the settings of the beam. So this is the size of aggregate that will be used to mix for the concrete of concrete that will be casted to the desired shape of the beam. So we have finished with beam. Now we'll go for column. Same apply to it, reinforcement. Now we have the minimum size, we change the grades, then we take 16, we say OK. Now the maximum 2, we change it. We can say the maximum here should be, let's say, 25. Then we have what we call the length bars, the lengths of the column. So we change the grade and we change it to Y10, while also this one, the grade shall change, and this one should be Y10 again. We don't have issue with this again. Now as you can see, maximum class spacing, minimum, and maximum center spacing. Now class spacing means the cover. Now the cover for the column can also be 30 or 1 inch, that is 25. So we can make it to be 30, which is okay. Now the spacing minimum is 200, and class spacing for the shear links 100 minimum and maximum 400. Then we have detailing option. You know, kicker mostly 75, that is 3 inches, which is very okay. Cut length around increment 25. Same applicable to beam. Assume foundation depth for starter bars. So we can assume depth of foundation here. If soil test had been conducted, so you can input your parameters here. So let's say we are designing one-story building. They said not exceeding 1.2 meters. So we assume this, but when soil test has been conducted, they will give you the foundation depth. So you input it here. So we have the links. So the links, we have different types of links. So as you can see, this one has been chosen, not this one. So this one is okay. Then we have general parameters. Bar size no smaller than stacked above. These are default settings which are very okay. So that is that for the column. Then we go for walls. We can design shear walls here. So for the walls, we'll change the minimum to Y10, while the maximum to Y25. Then we have our class spacing. For walls, 50 is okay. Spacing center is okay. This one, they are all okay. So we have horizontal, the spacings too are okay. But the confinement bars, this one should be Y10, while the other one, the maximum, should be Y25, within the range. Now also vertical bars in end zone, this one too, we'll change the grid, and this one should be Y25 maximum. So within the range, anything can happen. No, I have not touched it very well. This one I said should be Y10, while this one should be Y25. So as you can see, it is set. Also this, the grid should be changed. The reinforcement should be Y10. We OK it. Then we change this, and this should be 25. So as you can see, we have this. Then we have horizontal bars also should be, let's see, Y10, which is very okay. That is setting for the shear wall. Then we'll go for the detailings option. As you can see, they are all okay. So this is the type of shear links that will be used. Then the general parameters, which are very okay. That is that for the wall. Now we'll go for the slab. As you can see, reinforcement for the slab, we'll take Y minimum, Y10, maximum, we'll take Y12. Then we have clear spacing, which are very okay. And this clear spacing, minimum spacing, slab auto design. So clear spacing, that is the concrete cover. We can use 25 here, and all the settings are okay. No, this one should be 100. The clear spacing 100 is okay, while this 50 is okay. No, it should be 25. Then we have our flat slab, setting for the flat slab. Also this one should be 10. Then this one should be 12 also, the maximum, as you can see. So all settings are okay. And for these two, should be 1 inch, 25. So auto selection of bars. And we are finished with this. Then for the patch, we have patching in our slab. So column patch, clear width, that is at x-axis and y-axis, 4 meters. So you can change it. This is for the settings. We have beam patching also, width 1 meter by 2 meter. We have wall patch, we have panel patch. So for all patching, these are what we have. If you want to use mesh, you can use this, but if you want to use reinforcement for the patching, you can untick this. So we decide to leave it for reinforcement, not for wire mesh. So general parameters for the slab, the size of aggregates also is 20 mm. So it's very important for you to capture the size of aggregate that will be used for the concrete work. So we'll go for foundation now. Under foundation, we have general, minimum distance from column, wall face to base cap. This is minimum, is okay. Now we have what we call the isolated pad. Under the isolated, the minimum bar, we select Y12, while the maximum we select let's say 20, which is very okay. All the settings are okay. As you can see, bar spacing increment is 25, that is there. Then we have for piles also, this one 12 is okay here, while this one, as you can see, the 25 is okay. Maximum, depending on the magnitude of the structure that you are going to design. So that is that about this. Then we go to foundation size. This foundation size, it will usually design it auto design for you, but the settings here are okay, as we can see. No need of touching anything. Default pile, so we have different shape, rectangular or triangular, so you can change it when you designing. So we have general parameters. The general parameters also are okay. The aggregate size, the piles aggregate size also. Then we have the piles numbers, also they are okay. Then the mats, foundation, reinforcement. For this we'll take 12, and for the maximum we'll take Y25 also. And all these are okay too. Then for the patches of the mat foundation, also they are okay. Same applicable to our slab, as you remember. Then the general parameters, the nominal aggregates. So that is that about foundation. As you can see, we have our composite beam, we have our design forces. All these are okay. Design groups, we are talking about column now. Beams, concrete, and the columns, concrete. So we have our they are asking us members to be designed using groups. So beams and concrete, while this one will be alone, differently. We have our auto design, just design wind drifts. So the important thing is this: we have set the reinforcements, we have our loadings, we have our structure defaults. In our structure, nominal cover, as we set, you see nominal cover of beam 30, of column 35, and of wall 25, of slab 30, of pad base 40, which are very, very okay. So load case, we can use our load patterns, and default type. This means that TOS in SSL, top of steel, slab, top of steel member, top of slab member, steel slab level, top of foundation. So these are settings that will be used during the design, and that is the design level of the story. We have grid and construction lines, the extension, it will be extended with 500. So after finishing all this, as you can see, we have drawing settings, layers, options, planner, how you want to see your drawings, exports, layers. So drawing planner, we have plans, we have the foundation, to general, this is for the beam, how do you want it to appear, your free page, your arrangement. So we use the default settings for all. Then when you finish, you OK it. Now everything is set. This is our pre-settings. So for you to start your design, you go to new. You're new here. So our software now is ready for our design. So this is the end of the first tutorial, that is the pre-settings of the structural design. So when we are going to start our design, we have what we call the model settings. So with this, I, Engineering Technologist Rilwan Mikael from Zaria, Kaduna, Nigeria, saying to my viewers, well wishes. Thank you very much and stay tuned. As we meet again in the next tutorial, we'll continue from the next class. Thank you.